Hello and thank you for watching my series on geometry. This is lesson 1.3, distance. The objective of this lesson is to use the distance formula to find the length of a segment. The distance formula is the formula that finds you the distance or the space between two things, specifically 2 points. We refer to that as the length. For example, here, given the 2 points at the end of this segment, where the coordinates are x1 and y1, and the second point is x2 and y2, we can find the distance between those 2 points, or the length of this segment here, by using this distance formula here. So we plug in an x2 and x1 and subtract that, raise it to the second power, plug in a y2 and a y1, subtract those, raise that to the second power, and add it. Finding the square root of that then gives us the distance between those 2 points, or as we refer to here as the length of that segment. On this slide we just have again the formula again, just referring that we use the distance between the 2 points of x1 y1 and x2 y2 by the same formula as in the previous slide. So let's look at some examples and practice some examples of finding the length of a segment. So on this example right here, we will begin by first identifying the x and the y coordinates. So I'm going to make myself a little t-chart here. The x and the y coordinates of the following 2 points. Those 2 points right there. We'll begin with this top point here. We'll begin with this one right there. The x and y coordinate for that is -5, +3. And the x and y coordinate for the bottom point down here is -2, -3. We now want to plug again these numbers into this formula. So let me write the formula again. x2 minus x1 squared plus y2 minus y1 squared. So the distance between these things is going to be the, again, calculation of this formula right there. Well, the y values are these two y values right there. We want to subtract the second y by the first y. Well, here it doesn't really matter which one's the first or second one. I'll refer to the top one as the second one. So the second one minus the first one, that would give us -5 minus -2. And we're going to raise that to the second power. We're now going to subtract the second y by the first y. So our second y is the one on top, our first y is the one on the bottom, y1 would be the one on the bottom. And again, if you write this in a different order, it would not make a difference. You'll still get the same answer. We have 3 minus -3, and that's also going to be raised to the second power. From this point on, we can do this step by step, but I'm going to take a little shortcut here, and I'm going to go to my decimals calculator, and I'm going to solve this all in one single step. So I'm going to start by typing in first the square root, and then in parentheses, we have again -5 minus -2 to the second power. So that's what we're going to write in our parentheses. We have -5 minus -2, close the parentheses and raise that to the second power. We are then going to add in our second parentheses 3 minus -3, and again raising that to the second power. So 3 minus -3 and raising that to the second power. There we go, 3. And our answer is 6.71, or just simply 6.7. So the distance between these two highlighted points up here and the length of this line segment there is 6.71. So if this point was point A and this point was point B, AB, the length of that line segment would be 6.71. So those again are the two perspectives, the two ways of thinking about this. We're figuring out the distance between those 2 points, or we're figuring out the length of the line segments. And there's just again, these are the two different notations to represent that idea there. Let's go to the next example. Let's move on to the next example. Here we have the 2 points, and they want us to find the distance between those 2 points. They don't label them as A or B or any name of the points, but we again use the same formula as before. I always like to, especially when I start off with my students, to write my points in order as an ordered pair into a into a T-chart, just again so we organize our numbers and don't make a mistake of subtracting the wrong things, subtracting an x with a y or vice versa. So in the first parentheses, I want to get the second x value of -4 and subtract it by the first value of x1 and raise that to the second power. I am then going to add the difference of the y. So I'm going to subtract the second y by the first y, and that would be 1 minus -1. I'm going to raise that to the second power. So our distance would be the following. And again, I'm going to kind of cheat here, just a little shortcut, and use the calculator to calculate this a lot quicker. So we're going to write, if I could remember the numbers easier, there we go. -4 minus 3 raise that to the second power, and I am then going to add 1 minus -1 and raise that to the second power. So 1 minus -1. Oops. There we go. And we get an answer of 7.28. So our distance is 7.28. So in our third example, again, we want to calculate the exact same thing. We want to know, again, in the x coordinate plane, what is the distance between the 2 points. So just stick it into our formula. We're going to subtract the x values, which are these two numbers. So 5 minus -2 to the second power, and then we'll subtract the two y values, so 7 minus 3, and raise that to the second power. This time, I am going to take it a step-by-step process, okay? So 7 minus -2, that's equal to 7. So 7 gets raised to the second power. 7 minus 3 is equal to 4. So 4 gets raised to the second power. 7 to the second power is equal to 49. 4 to the second power is equal to 16. And adding 49 and 16, well, that's equal to a total of 65. Now, taking the square root of 65 is going to give us a decimal value, but as we see right here, our example is already inside the square root. So our answer is going to be letter E. We have the square root of 65. Now let's go into the next example. Here we want to know the length of PQ. So we're trying to find the length of PQ. But again, we use our distance formula to figure out the length of a line segment, or the distance between 2 points. Since they're giving us the x and the y value of our point, we're going to use again the same formula as before. So we're going to have 5 minus 1, raise that to the second power. 4 minus 1, and raise that to the second power. And again, that will give us the distance between those two highlighted points. So I'm going to do this again without the calculator and just do this again one step at a time. 5 minus 1, that's equal to 4. So 4 gets raised to the second power. 4 minus 3, that's equal to 3. And 3 gets raised to the second power. 4 to the second power is equal to 16. 3 to the second power is equal to 9. And 16 plus 9 is equal to 25. So the distance is equal to 5. The square root of 25 is equal to 5, so we have a distance of 5. So letter D would be our answer. And again, the distance between those 2 points is the exact same thing as stating that the length of the line segment is equal to 5, which is exactly what we studied in the previous section, section 1.2. How did it refer to as the distance or the length of a line segment? This is the way we describe the length of the line segment, and this is how we refer as the distance between the 2 points. Now in our fifth example, we want to again have the 2 points, and we want to know the distance between point P and point Q. So again, we refer to using our distance formula, that D is equal to the square root of x2 of minus x1, so negative 2 minus 2, raise that to the second power, and y2 minus y1, so 2 minus 0, and raising that to the second power. Well, negative 2 minus 2, that's equal to negative 4, so negative 4 gets raised to the second power, and 2 minus 0 is equal to 2, so 2 gets raised to the second power. Negative 4 to the second power, that's equal to positive 16. And 2 to the second power is equal to 4. Now in this example, I didn't put the 2 in square roots because again, it's positive, so it wouldn't make much of a difference. But a negative 4 it has to be inside this, in the parentheses, not square root, I meant to say parentheses. That has to be in parentheses because negative 4 in parentheses to the second power means I'm multiplying negative 4 times a negative 4, which is going to equal to positive 16, which is what we should get every single time. These numbers, when we raise them to the second power, should always end up being positive. Now adding 16 and 20, we get the square root of 20. And let's see what that's going to equal to. Let's calculate that. Let's go to our calculator because it doesn't match up to any one of these numbers. Well, obviously it's not going to be letter A and letter C. It's not going to be 4 and 6. So it's going to be either 2 times the square root of 5 or 4 times the square root of 5. So let's see what the decimal approximation is for the square root of 20. So the square root of 20 is approximately 4.47, and 2 times the square root of 5 is equal to the exact same number, while 4 times the square root of 5 is equal to 8.94. So the square root of 20 is the exact same thing as 2 times the square root of 5. So there's our answer. So 2 times the square root of 5. So letter B would be the correct answer. And for our sixth and final example, here we're asked to figure out the area of the square region. Well, to find the area of a square region, I need to multiply the length and the width. Well, in this case, because it's square, the length, let me highlight it, the length and the width are the exact same size. So length times width would be, again, 2 identical sides, which is shorthand for that we're multiplying 2 identical sides. And let me not use that notation. Let me use this notation instead. Length times width, which is basically multiplying 2 identical sides, is written as x squared. So the formula to figure out the area of a square is simply raising the side, whichever of these 4 sides, and raising that to the second power, meaning again we multiply it by itself. But here's the problem. I don't know how long this side is, or any of the 4 sides, but I do know that these endpoints, these 2 endpoints, have those following coordinates. So what I can do is find the distance between those 2 endpoints and thus figure out the length of this segment. So let's do that. Let's figure out the length of this segment. So we're going to subtract the x's, so that's 1 minus 4. That gets raised to the second power. We're going to subtract the y's, 5 minus 1, and raise that to the second power. And that's going to give us the distance between those 2 points. let's call the points again A and B. We'll call this point A, we'll call this point B. So we're finding the length of segment AB. Well, 1 minus 4, that's equal to -3. 5 minus 1 is equal to 4. Again, both of those numbers get raised to the second power. -3 to the second power is equal to 9. 4 to the second power is equal to 16. And 9 plus 16 is equal to 25. Well, the square root of 25 is equal to 5. So the length of A to B is equal to 5. And again, remember, I just named it AB. I just picked the name AB. So the distance between point A and point B is going to equal to 5 units. Well, again, because it's a square, that means that this side is also going to be 5. And because we're asked to find the area of that square region, again, we're trying to do this. This is what we're trying to do. So I just simply need to multiply 5 by itself. So 5 times 5. The area is equal to 5 times 5, which is equal to 25. So the area of this square region is equal to 25 units. So letter D would be the correct answer. Well, that concludes again the examples on this lesson. If you do have any questions, please do not hesitate to email me or send a message through Remind. Well, thank you again for watching and have a good day.